In this module, we shift from concepts to daily operations with Managed HSM. You'll see how enterprise teams create or import keys, rotate them safely, and then back them up, restore them, and protect them, so regulated workloads stay secure and continuously available. You've already built a strong foundation: why HSMs exist, core crypto concepts, and how Azure's security pieces fit together. You chose the right HSM option, designed patterns, provisioned managed HSM, and wired permissions. Now we'll focus on operating it securely in real environments, and then we'll move on to locking down networking and private access. Key lifecycle management is about treating every cryptographic key as a managed asset, not a one-off secret. With Managed HSM, keys are created or imported, then enabled, used, rotated, backed up, restored, disabled, deleted, and finally purged, end-to-end inside FIP's validated hardware. Around that lifecycle, you define ownership, access control, auditing, and recovery plans. Together, these controls reduce operational mistakes, insider misuse, and compliance issues. Before you create any key, decide exactly what it's for. Is it encrypting data at rest, signing tokens, or wrapping other keys? That purpose drives the algorithm and key size based on security, performance, and what your applications support. Then define lifecycle details: when the key becomes active, when it expires, and whether it starts enabled. Finally, standardize naming, ownership, and tags so you can prove compliance and manage keys at scale. RSA in Managed HSM is usually your default when you need maximum compatibility with existing apps, identity systems, and legacy protocols. RSA 2048 is typically the sweet spot, strong enough for most workloads and still performant. RSA 3072 and 4096 increase security margin and key lifetime, but cost more CPU and add latency. Use larger sizes only when policy, risk, or regulators require it, especially for high-value signatures or long-term archived data. Elliptic curve keys shine when you care about fast, modern digital signatures. Compared to RSA, you get similar security with much smaller key sizes, which means less data to move, lower CPU usage, and better throughput in your Managed HSM. The trade-off is compatibility. Confirm that your chosen curves are supported by your applications, SDKs, certificates, tokens, and end-to-end signing workflows before standardizing on EC. A Managed HSM key is really a bundle of three things: what it's allowed to do, how it's configured, and what state it's in right now. Operations like sign, verify, encrypt, or wrap should be scoped to a specific use case, not every possible action. Attributes such as enabled, start date, and expiry date define when it's usable. States like disabled or expired act as safety brakes, preventing silent misuse of forgotten or out-of-policy keys. When you create a new key, think about how it will be created, not just where. The portal is great for experimenting or one-off admin changes. As soon as you repeat something, move to CLI, PowerShell, or SDKs so you can script it. At scale, prefer infrastructure as code. Templates encode key type, size, allowed operations, naming, and tags. Whatever method you use, tie creation to change management and ensure only authorized roles run it. Bring your own key means you generate and own the key in an external, trusted HSM. Then import it into Azure Managed HSM without ever exposing the raw key. During import, the key is wrapped and transferred over an encrypted channel and can only be unwrapped by the target HSM. Because this key predates the cloud service, you also need strong governance, documented ceremonies, approvals, and custody records for every step. Key import failures usually come from two places: bad assumptions and missing records. Before you move anything, verify that the key type, algorithm, size, and format are all supported, and that your applications can actually use that key. Keep a clear chain of custody from generation through wrapping, transfer, and validation. Don't import weak, unknown, or heavily reused keys. And always test imports in a safe environment and design a rollback plan before touching production. Think of a key name as a stable identifier, and each rotation as a new version behind that name. Applications should always encrypt, sign, or wrap with the currently active version, but be prepared to decrypt and verify with any older versions still in use. So rotation isn't just a button click. You must plan how apps discover the new version, when data is re-encrypted, and what rollback looks like if something fails. Rotation is really a repeatable workflow. Start by reviewing your policy and deciding whether this key follows a manual process or an automated schedule. Then create a new key version and update any application references, especially if they point to a specific version. Next, validate end-to-end behavior in a test or canary path and monitor closely for errors. Finally, once everything is stable, formally retire the old version and record the evidence for auditors. Backup and restore is your safety net when something goes wrong with managed HSM keys. A backup captures both key material and metadata and writes it to an encrypted file. That file must be treated like crown jewel data, tightly controlled, stored in secure locations, and governed by clear retention rules. Recovery planning then defines who can back up and restore, and how often restore drills are run. So an incident becomes a routine, rehearsed operation. Soft delete works like a recycle bin for keys. When someone deletes a key, it isn't gone. It moves into a recoverable state for a defined retention period. Purge protection then acts like a safety lock on that bin, blocking anyone from emptying it early. Together, they give you time to detect ransomware, catch insider mistakes, prove to auditors that keys are controlled, and tightly govern high-risk delete and purge actions. You've seen how managed HSM becomes a governed crypto platform, not just a service. Design keys intentionally with the right types, operations, and metadata. Treat BWalk as a controlled import with strong evidence and validation. Then rigorously rotate, back up, restore, and protect deletions. In the next module, we'll secure access and connectivity.